Data on Kubernetes community live stream number 146. Extra excited about this one. We've got an awesome guest today with us who's going to be sharing all about OpenFeature, CNCF sandbox project that is absolutely rocking it when it comes to making features a commodity. And what exactly does that mean? We're going to figure that out from the perspective of developer experience, also with a bit of stateful knowledge in there, APIs, SDKs, all that kind of good stuff. Our speaker is no stranger to the cloud native world, the continuous delivery world, the Jenkins world, and many other worlds. Without further ado, Captain, we got lots of other things going on too. But I would like to welcome to the stage, Oleg. It is a pleasure to have you with us today. How are you doing?
Yeah. Hi, thanks a lot for inviting me. And yeah, I'll try to match Bart's level of energy today. So I'll try to speak as fast, but let's see.
Okay. Yeah, you're probably right. That's a good reminder for me to probably take a deep breath and slow down because we don't want to rush things too much. That being said, folks, we do want to get a reminder in here that our CFP is open for DoK Day. That will be on October 24th. I had the pleasure of getting to know Oleg actually in the last KubeCon in Valencia, and this is once again showing the power of community, whether we're online or offline. That being said, just going to leave the link for our CFP that is open. We've got lots of talks that are coming in. If you're interested in giving a talk, please reach out on Slack. We'd be happy to hear your ideas, help you brainstorm. But take a look at the CFP, and like I said, let us know if you're interested in giving a talk. That being said, though, Oleg, can you just give us a little bit of background about who you are, how you got into the cloud native world, and then we can see what we're going to be looking at today in your talk.
Okay, so I'll probably start from sharing my screen because as many speakers, I put the intro slides there.
Good stuff.
But, yeah. So as you can see, I'm doing the presentation from Windows today, prepared to some interesting moments. And yeah, do you see my screen?
Yep, looks great.
Okay. Yeah, so yeah, today we are talking about OpenFeature. It's one of the projects I'm participating in, and yeah, it's about standardizing open feature flag management. And as I usually say, making feature flags as commodity, because I came from CI/CD world where we try to make everything as commodity, and feature flags should be them too. Okay, just a brief dive to the history. Actually, I come from hardware space. I started as hardware engineer, especially hardware verification and test automation. And yeah, I have a PhD degree in hardware. And actually, this is the first ever feature flag I had experience with. This jumper, which you can see on pretty much every board. Sorry for the background noise.
It's all good. It's all good. Sharing is caring. This is good. It makes these things human. I love it.
Yeah, I guess he enjoys whatever cartoon right now. Okay, yeah, about jumpers. This is a way to manage hardware. Usually you can change the position. If you do it by your hands or by something not conducting, then it's perfectly fine. If you use kissers for that, most likely you will also do smoke testing in parallel. But yeah, this is how we used to do it in hardware, and it was quite handy. Obviously, with modern tech, it changed. Okay, about myself. I joined the open source world in 2012. Actually, I became a committer in the Jenkins project. How it happened? Yeah, when you do hardware testing and test automation, you need proper tools and frameworks for automation. So I started using Jenkins. Well, then I started fixing bugs. So then I somehow ended as a Jenkins core maintainer. Well, that happens. And actually, in my projects in Jenkins and in others, I've been using quite a lot of feature flags. That's probably all of you, because if you use system properties in Java, if you check environment in your Golang code, you, to some extent, already use feature flags. Nowadays, I work at Dynatrace, and it's open source program office. There I work on Captain. It's one of the projects which has been already presented at Data on Kubernetes meetups. It's a tool for managing cloud native applications and managing life cycle of that. It's been driven on observability, etc., etc. And yeah, I also help with OpenFeature project. My main activities today is just helping with community, governance, CNCF relations, and all stuff like that. I also helping the team because there is a new governing board. Nobody had experience with governance before, and I help with that. I've been on Jenkins governance board for something like 3 years by now. I am at TOCG and the CD Foundation, and all this bureaucracy is actually quite exciting to me. So life happens. Okay, some bits about Dynatrace also. So Dynatrace actually is quite an active contributor in open source world. We are top 4 contributor to Open Telemetry project, and we also participate in many other projects and foundations. And we believe that open source standards is actually one of the ways to grow the ecosystem and to ensure interoperability in this ecosystem. So apart from Open Telemetry, which is also observability standard, we also started a project called OpenFeature. I will be talking about it today, and we also contributed to CD events. It's a project in the CDF based on cloud events. And yeah, we do quite a lot of other engagements, activities in open source ecosystem. So if you see a Dynatracer submitting a patch, it's probably one of the results of Dynatrace OSPO work, because we try to make it easier to thousands of engineers we have in the company. Okay, let's go back to the talk. I will briefly talk about what feature flag is, just in case. Then we will talk about OpenFeature. I will show a live demo, and then we will talk about what's next in the project, and do a deep dive in its roadmap, and talk how you could participate in this project if you're interested. Okay, so let's start. One thing I forgot to mention, these slides are already public, so I guess Bart could share a link in the YouTube channel so that everyone could access it. That's why all the links, etc., they are public and you can navigate them.
Yep, we'll share that link right now.
Okay, thank you.
Yep.
Okay, so what are the feature flags? I have already shown you a jumper, but of course in open source there are many other implementations. But the idea is quite simple. It's a value that can be checked, and this value defines a behavior or a state of your application. It can be used for different use cases. So for example, preview features. You want to deliver something new, for example, dark theme for your application, or whatever custom behavior, custom control. And you can hide this behavior under feature flag so that you can enable it or disable based on some conditions. You can use it for various kinds of A/B testing. So what we see a lot with SaaS services these days, when you roll out just one version of application, but based on your location or based on your username or whatever, you have different behavior. The company can collect the feedback, experiences, can monitor that, and then decide how to proceed and what feature actually roll out. Then various kinds of progressive delivery, and sometimes even settings are considered feature flags, because if you have settings in your application, it's also a kind of runtime configuration, it's context, and it could be connected to feature flag management. A few logistics things. So there is no unified terminology for feature flags. So again, some people consider settings as feature flags, some people not. But generally, a feature flag can be temporary, short-term, long-term. So the idea that you deliver it, you evaluate the feature you delivered, and then you basically remove this feature flag and get it as a part of your application, if everything is fine. Or permanent, it's just whatever trigger that alters the behavior, like some kind of advanced feature, etc., etc. Feature flags can be runtime. So when your application runs, every time you can change the value and the application reacts accordingly. Or it can be just defined on the startup, especially in older applications. And there is common misconception that feature flag is only a Boolean thing. And actually, it's not correct. Feature flag can have a value, it can be even string or whatever. It depends on your application, use cases, and your needs. Let's take a look at a few examples. So one example is rather modern. I believe everyone is a GitHub user, and in GitHub you can go to the top right side, click on your profile, and click feature preview button. And now you can see 3 features there. So command palette, colorblind themes, and also project migration for GitHub projects. This list constantly changes, but ultimately it's a way for GitHub to evaluate new features and a way for GitHub to provide them. So it's a kind of feature flag controlled from the web interface, which you can try out and then decide whether you need it or not. Another example, I took how we do it in Jenkins. Full disclaimer, it's not how you probably should do it in 2022. But initially, if you have a Java application, you may have a system property. It's a natively supported way to pass various configurations in Java. So when you start the application, you can pass a value. And moreover, you can change this value in runtime. For example, in Jenkins, if you use the system Groovy script, you can also change the flag. And historically, we used this behavior to define the various configurations. So there is a page called System Properties. I will be navigating to my web browser quite often. And even if you take Jenkins core, it takes quite a while to scroll it. And you can see that some feature flags have been introduced quite long ago, so they still have Hudson in the name. So the assumption that feature flags get removed, it's not always true. Why we use these feature flags? First of all, we try to define some logic. So for example, we have Hudson lifecycle. It's a kind of system flag where we define how we want to start and stop Jenkins. For example, it behaves differently on Windows, on Linux, inside the Docker containers. And we can basically override this behavior if you want to enforce particular one. We can also define various security bypasses like skip permission check, makes your instance insecure, but nice for debugging. Also, we have development flag that switches Jenkins into development mode. You can switch in the runtime if needed. And also there are various kinds like timeout, etc. Again, we have hundreds of these flags for all kinds of cases, but it's just a few examples how you could use feature flags. And again, feature flags are not just tumblers. Actually, how it happens these days, feature flags are usually evaluated. So instead of just passing system property like we do in Jenkins or having a trigger, you actually may have quite complex logic that makes a decision of what value to set based on a few conditions. So for example, context may be based on your user. So you can enable feature flag for a particular user or for a group of users probably. Can be based on location, on languages, on instance ID. It could be fully randomized if needed. And of course, it can be based on control plane inputs. So you can have a supervisor somewhere in your system that defines the value for your use case. Or it can be defined as by a user, for example, like I've presented in the GitHub example. So all of that are still feature flags, and all of that have various implementations. So most of you probably tried out various feature flag libraries, and spoiler alert, there are many of them. Actually, there are dozens and hundreds just open source projects. There are many vendors providing enterprise solutions. And yeah, it happens for a reason, because everyone needs different things for different technologies. What is general for them? Mostly SDKs are open source. So when you include, let's say, Launch Darkly or Cloud-based feature management or Split, all of them provide open source SDKs. So you can verify them, include into your project, and then connect to external service that manages feature flag, which is of course SaaS, proprietary, but at least you can use it. And the problem is that there are many technology-specific SDKs, and so if you do Java, if you do .NET, if you write in Golang, every time you may need a separate SDK library, and also there are many services. So basically, it has a huge configuration explosion, and sometimes you are stuck to a single implementation. The problem with that ecosystem for each particular implementation is limited. let's say your Kubernetes developer or Jenkins developer, would you go with a particular feature flag implementation? Probably not, because it's still vendor locked, and it has limited capabilities, and it's not a default open source, for example, like OpenTelemetry. Also, sometimes implementations are not very cloud native. They needed features, and they lack observability and integration with other standards. So when we were looking at Dynatrace, basically how our project started, we wanted to use feature flag management for Dynatrace platform itself. And we found no implementation that would suit our needs. And then common problem starts. So what do we do? Yeah, I guess everyone has saw that, and we decided that we approach it common way. We want to create a new project. But since Dynatrace is dedicated to open standards, we believe in OpenTelemetry and company, we decided to try out the same with OpenFeature. And this is actually how the project was born. So we took a few assumptions. So yeah, we wanted to have open standard that would be vendor neutral, and it could be adopted by everyone. We wanted to develop unified and open source APIs and SDKs so that everyone could just reuse these components and follow the standard. We also want to provide cloud native implementation for management with control plane, because Dynatrace is all in Kubernetes. Our new slogan is cloud done right. So we need something cloud native, of course. And nevertheless, if you develop open standard, you need vendors to adopt it. So supporting extensibility for commercial offering is, of course, a table state feature for that. So there were many discussions, implementations, and finally we decided to go with a public project, which would be mostly focused on Kubernetes with reference implementation, which would have open specification, and that would have many implementation. And this is what is OpenFeature is. So if you're interested in OpenFeature, so firstly, thanks a lot for coming to this talk. And if you go to OpenFeature dev, you can find all the information and references. So all I will be presented today is more or less linked from this website. But yeah, I want to provide some excerpt. What's the main idea behind the project? You take, in your application, you take OpenFeature SDK, which is open source. This OpenFeature SDK also has adapter called provider that allows to integrate with particular vendor SDK if needed on client side, or it can be a standard implementation which talks to external service, and then you don't have any vendor specific code inside your application. And then it connects either to external SaaS vendor service or to local feature manager, and you can start using that. The project itself actually started just a few months ago. So we announced it at KubeCon in Valencia, but it started just 2 months before that. The thing that even if it started once it started, we got so many interest from potential contributors and vendors. And by now we have almost every feature flag vendor, open source or not, participating in the project. And by now, so if you check the list, there are companies like LaunchDarkly, Flagsmith, CloudBees, PostHawk, etc., etc. So again, this ecosystem is quite big, and all of them started implementing the adapters and integrations. So the standard is definitely something they needed. Firstly, because nobody wants to maintain dozens of SDKs, and everyone wants to get a better adoption. And actually having open source standard, making communication layer and feature flag itself a commodity is a way to do that. Moreover, the project became officially a CNCF sandbox project in June. We applied, I believe, in April. In June, it was approved. So now it's a CNCF project. And of course, if you go to KubeCon in Detroit, you will be able to visit us. We are waiting for the booth confirmation. But anyway, there are talks about feature flags, and of course, there will be community there. I'll briefly glance through main parts of that. And first of all is open specification. Open specification, how it happens. It's a GitHub repository with all the information and a bunch of JSON files and YAML files defining the specification. Or moreover, there are some tools like specification parsers implemented in Python, just in case you want to integrate with tooling for verification, etc. Somebody has already tried to create a verification tool for Visual Studio Code. And there is a lot of information there, but basically we try to define what types of feature flags are there. So for example, Boolean, string, etc. And then the format, how it's being communicated to users. So here, for example, in specification, you can see how flags are evaluated. So it shows actually what features are supported and how they can processed. How they can be processed. So there is a lot of requirements. So this specification is not fully complete. We haven't released yet, but it's there. Also, one of choke points for us was, of course, evaluation context. So this is information about user session and everything that is needed for feature flag decisions. And you can see that there is a bunch of activities and there is a bunch of issues. So how this work happens, so there is some information about the beta roadmap, what needs to be done before the specification is released. So if you are interested, you can participate. And for engineers that who already want to try it out, we also have Playground. This is a repository which actually contains various integrations and various demos you can try out for SDKs. So it's Node.js, and I will show it later how it actually works. But what I wanted to show is that already we have quite a lot of integrations there and quite a lot of reference implementations. So for example, tools like Split, Cloud-based feature management, LaunchDarkly, Go feature flag, all of them have some reference implementations that which you can use and try out. And members of these communities and these companies, they participate in the project. So basically, this is why specification takes quite a while to complete, because we have so many people trying it out and trying to reach consensus. You may have seen the same example in OpenTelemetry that stayed in sandbox, I believe, for 2 years in the CNCF. And well, I think that it's good if you want to actually create an open standard. So it will take a while until it lands, but progress is being done. So again, for those who want to try it out, we have several SDKs ready. So for Node.js, Java, Golang, .NET, and .NET Framework, I believe starting from version 3.5. Also, there is a prototype implementation for Python, and we also have quite a demand in other implementations. So if your language is not listed here, probably it's one of the ways to participate, actually try it out and implement something. You can see that our roadmap here is not particularly awesome, because we decided that everyone likes Golang. There are many Java contributors, Node.js contributors, there are also companies using .NET. But for example, there are no Ruby users. There is no users of many other languages, and there is definitely an opportunity to create something more. Hopefully we will get there over time, but now with specification being a moving target, we try to minimize the number of SDKs. So a few items about providers, and then I will make a quick stop to answer questions if any, before we proceed with the demos, etc. So for providers, actually, we have quite a lot of them. I've shown some links in the demos. And actually, one thing I wanted to highlight, in addition to providers, is that we also have our own solid project called FlagD. So FlagD is basically a reference implementation for feature flag management, which we have right inside our repository, and which is being developed by several contributors. Probably, you know, Alex Jones, he's one of the main drivers behind this project. So basically, it's a containerized service which exposes OpenFeature API and interface to which everyone can connect and request feature flag evaluation. One of the specifics for OpenFeature is that we try to do feature flag evaluation on the server side when it's possible, because we believe that it makes the applications more light, because you don't need to inject all feature flag validation logic into your application and redeliver every time you need a new feature flag or a new condition. And based on this project, actually, we created Kubernetes native implementation. It's operator, which can inject a sidecar flag container into your application. So how it works, you have application which is OpenFeature compatible, and this operator has a lot of configurations which is applied by CRDs, of course. When you submit new CRD with configuration for your app, it creates a container for flag which interacts with the application and hence injects feature flag on that. So the interesting part about that is that you can instrument existing applications. It's quite good for debugging. And of course, if you manage Kubernetes applications at scale, using operators is one of the ways to actually manage the things these days. Last but not least, regarding features, we have embedded OpenTelemetry support, we required in specification itself. We have standard for events, and also in our reference implementations, we integrate by default. So when you do feature flags management evaluation, you also get full observability in what the heck happens in your system, which is quite important if you have hundreds of flags with users and context. Sometimes preview features, etc., lead to bugs, which is why we do previews, one of the reasons. And hence, observability is super helpful when you want to troubleshoot what happens, especially when there is influence of these configurations. Okay, before I proceed with the demo, are there any questions?
Just a couple quick questions.
Yep.
When it comes to starting open source project from scratch, getting that momentum going to get it to the point where you can say, all right, we want to get this in as a sandbox project for the CNCF. What have been the biggest challenges about that? About, whether it's about providing an offer that's attractive enough that folks are going to come and also that they're going to stay. I just say that for a lot of folks that are out there that are either starting an open source project or working on building it out, what recommendations might you give based on your experience with OpenFeature? Okay, so OpenFeature, actually, we kind of hit a honey spot because there was huge demand on the market for feature flags, and even vendors controlling, let's say, significant parts of the market, like LaunchDarkly, they immediately saw the value. So for us, when we were coming with OpenFeature proposal, it wasn't just in-house project. We actually were modeling OpenFeature, and we were targeting building a collaboration from the very beginning. So for us, actually, applying to CNCF was rather natural. But when we applied to CNCF, we already had more than 10 companies that started participating in the community. So for us, there are many kinds of open source. There are open source that started as in-house development tools. For example, Jenkins started like that, Captain started like that. And usually these tools struggle to get big adoption among vendors because they are not really designed to be served as a product. But for open specifications and for projects like OpenFeature, which are basically low-level frameworks, they can be designed for wide adoption. And if you manage to do that, if you manage to create interest among potential vendors and potential end users, then the project can skyrocket. So we know that OpenTelemetry is the fastest growing project in the CNCF. It grew something like 300% last year. Yeah. Hopefully with OpenFeature, we could reach the same. Yep. So this is key idea for this kind of specification projects. Find something that would be interesting for others and talk to right people. I think it's a great point. Like you said, is that it's a question of listening and understanding the value that's being provided, not just for a single organization, but that it's going to be providing benefits for others, just so that folks don't end up perhaps answering a question that nobody asked. We see that with some happening sometimes, like interesting technology, but is that really being demanded? Is there a pain point out there that's being resolved? And like you said, in this case, given the interest from the very beginning, it was only a natural step then to take it to the CNCF. Yes, exactly. So many projects apply to CNCF to improve their visibility. It can be a way
But if you want to have a fast-growing open source project, it should be viable without any foundation. And yeah, this, I wouldn't say that applying to CNCF or to any other foundation should be a mandatory step to make the project sustainable.
Great points there. Appreciate it. Let's go to the demo.
Okay, so before I do the demo, a fun fact about Dynatrace, we have green as our color, so you can see a cup. Okay, which is kind of fun.
Yeah.
Okay, so I wanted to show actually a big demo involving Jenkins, Kubernetes, and other things. But due to reasons beyond my control, today I'm doing the demo from my personal laptop that has 16 gigs of memory. And as you know, if you use Zoom, 16 gigs of memory is pretty much enough for Zoom. So today I will be doing quite a minimized demo. In the project, we have a playground, which I have already presented. So here we have a demo that can be integrated with different projects. This demo is based on Node.js. And if you want to follow this demo, you just follow these steps. You need NPM, Node.js, Docker on your machine, and basically that's it. If you want to follow or if you want to implement later. Most likely, yeah, you will be still waiting for NPM CI to complete when we finish this presentation, because it's NPM, but yeah. So I'll show how it works. So this is a simple demo. It has whatever front end with some emulation of user login. And actually there is some guidelines here which you can follow if you want, which demonstrate various features of this demo. But yeah, we'll just close this interface and show what we actually have. So this is the application which can run on various devices, etc. And this is our file. It's a JSON, and actually this JSON is supplied by FlagD. So this is the reference implementation I was talking about. Well, actually not FlagD, it's just supplied by API. So here we can edit this file, and yeah, we can just break this file, of course, to start things. And this application actually takes the data for this file. So now we periodically poll the application for flag values. And for example, here what you can see. So this configuration is a part of OpenFeature specification. So here we have 3 controls: new welcome message, which is currently welcome to SaaS. This feature flag is disabled, so we do not manage that. Also, we have Hex Color for this control, and we have algorithm for what we use. So here for Hex Color, it's quite easy. So we have 3 variants: red, green, blue, yellow. So this is a part of specification, and we have a default variant which is blue. So here we have blue. If we change it to red, it takes some time, and then the interface changes. So basically what happened, the API exposed this configuration file, then our application took this feature flag and adjusted. So I will roll back to blue. Also, you can see that there are some management things, and there are also various conditions. So there are rules that can be done based, can be applied based on different context. So for example, here in the configuration, we have context called email. So this is a part that the application understands how to handle that. And we have a condition which is ends with @fast.com. So for example, if I log in, what happens? Well, actually nothing happens right now because we just changed the calculation logic for this algorithm. And I click here and you can see that basically our Fibonacci calculation happens quite quickly. So here we applied this algorithm. If I log out, it takes a bit longer to calculate because we use a recursive approach. So Fibonacci of 45 takes some time. This is just one of examples of a feature flag that just changes algorithm. And basically that's it. So you can define your own feature flags, you can define all rules, the conditions are quite flexible. You can also manage defaults, etc. And basically based on your user, location, or other values, you can alter how this behavior works. And the API right now is stupid simple. So the API for default providers we have is just this JSON file, which can be generated by the server side based on a few conditions. Well, it quite works. We can take a look at the observability backend. I have, so if we go to the playground, not play Scrabble, though we can try later. Okay, so if you go to playground, here one of the examples we have in the bottom is actually monitoring. So we have OpenTelemetry support. We produce OpenTelemetry by default, and here I have a running container with Zipkin that actually just shows our observability things. So right now, we already have some traces submitted. So you can see that there are traces, well, basically implementing our API. So we get hex color value, we get message, we get for utils JSON. And for example, for hex color right now, we can show the trace. So you can see how it happens. So we basically go through request, and then our API service processes it, well, quite a long time, and then basically returns the data back from with different values. And here, for example, we know that the related variant is blue. So based on our conditions, based on parameters we submitted, we get that we are basically blue. And here you can see that there are some parameters which we pass. So this is an example, but this is a very simple example. I wanted to show you how I switch themes in Jenkins using feature flags, but it requires quite a lot of operating memory, so maybe next time. And yeah, here, if you're interested, of course, you can tinker with these files as much as you can. The format is defined in the specification, and of course, it's just a demo. So the real specification is much bigger, and we still try to extend it for different use cases. And soon, I hope we will start adopting the projects. We will have projects that adopt this specification. So, for example, in Jenkins or in Captain, or maybe in Kubernetes or whatever project you maintain. If you implement the standard interface, maybe we know what features are missing and what still needs to be added to specification so that we can support all use cases of feature flags by different projects, whether they already adopt feature flags through existing vendor or open source project, or whether they just want to start using it. Okay. So any questions so far?
So far, so good. But folks, remember, if you got questions, get them in the chat, and we'll be happy to get to them accordingly.
Okay. So for this file, yeah, what I discovered in this demo, so full disclaimer, that one of the things I tried to do is like that, and it will completely break the thing because we don't use proper text editor. As you can see, you can break it quite easily. And for your information, Control Z doesn't work either. So you will have to restart the session if you break it. But yeah, apart from the demo things, it's quite handy. And actually, instead of this demo, you can connect the same demo to any other backend. So, for example, I was demoing Cloud-based feature management because I used to work for Cloud-based before, but it again depends on my work laptop. But any implementation you would like to try out, you can do that. And maybe I would recommend Go Feature Flag because it's something that you can just run. It's open source project. And if you want, we can just try it out even now. Well, they use CURL, but yeah, I think I will be able to get it working on Windows. Okay, why not? We could probably try. Let's just stop everything then. So you can see that basically there were two commands running JSON demo, and also we had a service that was providing backend. So we don't, next time we will need UI, but we won't need the service anymore. So let's just try. Actually, I have CURL installed. It actually saves the time. So yeah, now the most difficult part. It's not going to work. Sorry. Okay, so I will just run a Go feature flag. So if you're interested to see what I'm running. So
we got a question.
Yeah.
And it's not just from anybody. It's a wonderful person who's in the audience, Strimsy maintainer, Jakob Scholz. So his question is this: I can see that in a big production environment with many deployments, having a central feature flagging service adds value. But sometimes you just don't want to run yet another service. So what are the possibilities to use, for example, environments, ENV, VARS in development and test, and some external feature flagging service in production?
Yeah, of course, since we do development, we don't want to run all the services, etc., on our own. So we have a few demo providers, or well, let's say providers that you can actually use in production as well. Environment variable provider, JSON file provider. So let's say if you just package a container image, you can just blast in a JSON file, or you can modify container environment variables even in runtime if your system supports it, and you get these feature flags without any services.
Alrighty. Got a little bit of delay always between the call and the YouTube, but I'm sure he'll follow up. So keep going. Thank you.
Yeah. So let's see how's our Docker domain. Oh, Go feature flag. So we have the interface running. Just to show the project I'm showing to you is Go feature flag.org. It's one of open source projects that's again doing feature flag management. Of course, it's focused on cloud native ecosystem on Golang, and we can use it. So I am going to just follow the demo steps which are presented there. So run through these commands. I did it. Then we launch the demo, but we launched the demo with Go feature flag demo because it changes the provider. So later we can take a look at the NPM settings, but basically it just changes the provider configuration so that our backend knows what to talk to. And I guess we still need is it already live? Not yet. So let's take a look what does Go feature flag. No, we don't expose interface there. Okay, so that is second. Well, due to whatever reason, I guess it's just one of the leftovers because the port changed. But here we can just show the same in the UI, which is still available. So I will run another cmd command, and then source open feature. Okay, let's see whether we were able to connect another backend. I'm not sure, and if not, something definitely wrong. Didn't go right in the demo, because we should see the interface here actually. Not found. Okay. I guess if it does not work, the key takeaway from this demo: never do demos without testing. Right?
That's okay. It's good to live dangerously sometimes.
Yeah, let's say I wasn't even planning to show it, but since we have some time, so you can see that there is a bunch of logs here, and you can see that the system went completely sideways because it's trying to load configuration which is not available. It tries to connect to the system which is not available. So I guess something went wrong with configuration for Go feature flag demo. Let's see whether we get observability running for this use case. Because yeah, this is actually when you go to observability to see what the heck is going on. And let's see. So since it goes to DNS lookup, I guess nothing good is going to happen here, right? So Go feature flag new. So it tries to do HTTP post and then it basically never returns. And here, well, basically the same. So we can see the trace of the request and we do not see any response. So I wonder whether we should get more diagnostics when there is no response from the service in this case, but well, at least we know where it gets stuck. It can just cannot discover the service it's looking for. Okay, demo failed, but you can try it on your own. And yeah, I'll take a look what's going on tonight. So probably I will submit a pull request for the fix. Okay, I'll spend a few minutes to just show where we are going with this OpenFeature. The initial plan was to do a beta release in August. Well, now it's August, so obviously we are not exactly there yet, but we plan to. So we are getting feedback, we are preparing to the release of the specification. We are still finishing some bits before it can be done. And there is a roadmap which actually shows where we stand at the moment. So the project is fully open, and all the roadmaps, etc., are also publicly available. So here you can see mostly roadmap for specification. So we have a bunch of things already landed. So currently in progress, Mike Beamer, he's my colleague, he's working on semantic convention for open telemetry. We also have some items for logging, and yeah, version mismatch behavior because we want to have versioning for specification. And the context propagation is also one of the topics which still needs to be finished because it's the most painful ones. And pretty much the same for other components. So for example, there is some research happening and going on. There are some SDKs as I've already presented, and many other things. So you can just go here and you can see where the project stands. We definitely want to have release by KubeCon so that we could present there, and there will be a number of events, including app delivery day, where this project can be discussed, and where hopefully we will have some presentations happening as well as at the main KubeCon. And from the community side, as always, the project is open for contributions. We established public governance, so if you can find all these governance materials here. I believe it's not interesting to almost everyone on the call, but if you're interested in how the community are organized, etc., all of that is here. Key standpoints: open governance, so everything happens in open. We have Slack channel where you can participate, channels, and all the decisions are made by consensus, so there is no dominating company. And for example, if we take the current governance, so we have a governing committee with 5 people to our backend for joining adopters, and also technical steering committee with 3 members. So this is how it works at the moment. From the community standpoint, so what we actually want to do. So we want to have more integrations, more adoption. I believe that OpenFeature is already available for evaluation. So if you're interested to try it out, just do that. There is FlagD, which is super handy. It's just a Dockerized container. the curated application with all the interfaces exposed. You can try it out, you can develop it, or as it was mentioned, you can just take a JSON file for testing. And currently, we definitely want to get more feedback from users to understand what's missing in the specification, what additional values and use cases you would like to get covered by OpenFeature. And once we get enough feedback, the better release would happen. When the general availability release happens, I do not know. I think it will take quite some time before it happens, but ultimately it depends on contributions. And everyone is definitely welcome to contribute. So if you want to try it out, then there is OpenFeature Playground, which the repository I've shown. You can connect it with whatever backend. Well, hopefully it works, not as it happened during my demo. But yeah, this is one of the ways to try it out. Also, you can take your project because it doesn't take long to get it running. Let's say with Java application, you just connect the library, connect it to the service by default, and start using it. If you're interested to participate, there is a Slack channel. The Slack channel is currently a part of the CNCF Slack. So if you're there, you can join. Also, there are regular project meetings on Thursdays. Next Thursday, there will be a meeting, for example. And you can also join interested parties. So this is our list. We add everyone who joins to our mailing list, the distribution, and also you can just start participating in the community. So here's our honorable list of people who want to participate, and hopefully we, through this number of participants, we will also get adoption quite soon. And again, any feedback is interesting. Any SDKs would be definitely interesting because there are so many technologies in the world, and somebody will eventually need to implement SDKs for them. Right now, it's not available for all the languages. I consider writing a C++1 just to refresh my C++ knowledge, but I assume that nobody really wants me to write it. So yeah, let's see. And here's a bunch of links. You can just open this presentation and find everything. So did we get any additional questions?
Yeah, I mean, one thing that you were mentioning earlier about OpenTelemetry having so much growth, and I think a lot of times Kubernetes is such a big protagonist, and gets a lot of attention, and we all love it. However, there seem to be some things in OpenTelemetry that, given that growth, and as someone who's been involved in lots of open source projects for quite some time, what do you find about OpenTelemetry that's so attractive, and why we see those numbers in growth, and what we can expect in the future?
Yes, so for OpenTelemetry, I believe that the main reason why it evolves so quickly that it's open specification, not just an open project, and that everyone needs observability. We reached, when OpenTelemetry started, well, it didn't start as OpenTelemetry, it started as multiple projects like Open Sensors, etc. And even now, projects are in different states. So, for example, traceability is, let's say, GA, but logs and metrics are not. But OpenTelemetry basically becomes a hub for all kinds of open telemetry for your applications. And maybe there will be some projects happening later. Why it got so popular? Nobody wants to create their own libraries. So I work for Dynatrace. Yeah, Dynatrace is quite successful when it comes to application monitoring. We have our own implementation, but yeah, it takes quite a lot of people to maintain it. And this why. So we provide it to customers. This is how we operate. This is how we get money. And for OpenTelemetry, again, for us, it's quite interesting because if your application is not compatible, so our agent, for example, one agent, it knows how to work with JVM, etc. It connects to it, it extracts data from common frameworks, let's say like Jetty, etc. And everything is written by our awesome developers who know how to do it and how to do it quickly. But it's still not possible to support all frameworks in the world. I mean, as we speak today, I guess there will be 2 or 3 new NPM frameworks created, right? And for that, there is alternate approach. Instead of implementing Kubernetes integration on your own, you can rely on open standard as an open source project or as a a vendor. You can implement the standard specification, and then all the bits they just start working together. So for vendors, it was useful because they didn't have to maintain all these integrations. They could still get value from what they had data. So even if you have submission to OpenTelemetry, you can have Prometheus storage, etc., for analytics with Grafana, or you can have tools like DoK or Dynatrace, which are super efficient, or you can take Zipkin from open source, Jaeger. It depends on your choice, on your budget, etc., But ultimately, data and how you handle this is where the value is. Traceability events itself became a commodity, so there is no point for many to implement this submission data and open standards. You can do it in some cases for better performance, etc., like we do at Dynatrace, but for majority of applications, you don't need. So you just connect OpenTelemetry, get data, and it was beneficial for users, for vendors, and for everyone in the middle. So the project started to go around rapidly. And at some point, if you have a huge collaboration between companies, then FOMA starts for others. Because if you're a vendor that is not integrated with OpenTelemetry, at the moment you are going to have a hard time selling it to your customers. So this is where the project basically becomes dominant, and this is where, well, basically integrating with it becomes a table stake. So if you can reach with your project a state when it's a must-have to integrate with your project. Like, for example, at some point it happened with Jenkins. You may like or may not like thousands of integrations, plugins, etc. Well, Jenkins is quite notorious, but it happened with Jenkins. At some point, you had to have a plugin if you wanted to be a part of CI toolchain. So now it happens with OpenTelemetry. Hopefully it will happen with OpenFeature, and the same with many other tools and frameworks. So for open source, it's a really sweet spot if you find a way to convince everyone that they need it. At some point, basically, you don't have to invest in adoption because others will have to come to you and adopt your project anyway.
Very good points. And like you said, creating a thriving, robust ecosystem where if you're a vendor and you're not there, then that's going to be a problem. So like it's like you said, that's a very strong reason for why it's continued to have the success and growth that it's seen. One question, because you mentioned something about frameworks, but a question that we had from the audience from Ravi was, will OpenFeature get more programming languages support?
Of course. So now as developers, we try to limit the number of SDKs. Because when the specification is moving target, before the release, maintaining multiple SDKs is quite an overhead. So we have a number of SDKs, basically what people need for the tinkering, and everyone is welcome to implement it. For example, there was a contributor who needed a .NET SDK, and they came and created .NET SDK, and it's great. Once the specification stabilizes, then of course there will be more investment in this ecosystem. But right now, having a stable specification would be a priority from my standpoint. Okay,
very good. Very active roadmap. A lot of things happening in OpenFeature. That being said, we are getting towards the end of our conversation. You mentioned this, but just go back to the notion of observability present throughout the talk. Something that we've talked about in the Data on Kubernetes community, and you briefly mentioned it as well too. Is observability something that's going to be moving over, or how do you see observability when it comes to the data space? As you said, data is the most valuable asset, or one of the most valuable assets an organization can have. When we talk about observability related to data, what are your thoughts on that? What are your expectations for the future?
Well, I think that observability data actually became important long ago, because before it was called observability, it was called application monitoring. And companies like Dynatrace, DoK, and many other vendors, Somologic, whatever, all of them appeared not today, not 1 year ago, but long before. And for big customers, for big enterprises that have huge infrastructures, it was already a table stake to have application monitorings and having insights into what happens in their systems. With Kubernetes, with a lot of microservices, with containers, well, basically single shot ones, all infrastructure became kind of fluid. So everything changes every minute. And without observability, you just won't be able to troubleshoot what happens in your system. So observability became a must, and this is why we see so huge growth of open source ecosystem around observability. For example, I'm personally a big fan of cloud events. So cloud events is one of the way to do messaging between systems in open source ways. I always put cloud events part of open source observability ecosystem because I believe that it's very important part, not less important that open telemetry. And what happens next? There will be more implementations, more vendors, and hopefully more contributors. Now, probably there is a kind of explosion. So like it happens, dozens of parallel projects, some of them will succeed, some of them won't. But eventually the ecosystem will stabilize. And I believe that OpenFeature as a standard will be one of the consolidation points for the ecosystem.
Good to hear that. And you heard it straight from the source, folks. So we will see what happens. Looking forward to what's going to be going on the next KubeCon with the updates about OpenFeature. Really easy to get involved. You've got all the links, everybody. You got the link to the slides as well, which has even more links. You can reach out, as Oleg mentioned, there's a Slack channel in the CNCF to get involved. And it sounds like a very growing and thriving community. Before we finish, in our own sort of artistic sense of observability, while you've been giving this amazing talk, we have our wonderful artist, Angel, who created an artistic depiction observing what you were talking about and put it into artistic form. So it's always a nice thing to sort of touch on as we finish, and a reminder about these are things that we need to celebrate. There's lots of cool stuff going on here. This is an incredible talk. I regret that this is the first time we're having you on the Data on Kubernetes community live stream. Certainly not the last. Hope to get a submission from someone in OpenFeature or in Kepton or one of the many other projects that you're involved in for DoK Day on October 24th. Oleg, this was a pleasure. Thank you so much for your time today.
Yeah, and thanks for inviting me.
All right, take care, everybody. We'll see you soon.